Let's take a look at another formula and how to manipulate it. The reason I wanted to do this, kind of continue a previous video, is this one here has some subtraction in it. And so there's a couple things to be aware of that I want to talk about. But let's manipulate this first, and let's try to solve for. Why don't we try to solve for VI? So that's the initial velocity. So let's take a look at this. This formula here, which is you'll see in Science 10, is acceleration is equal to the final velocity of an object minus the initial velocity of an object divided by time. Another way of writing this top part here that you'll see, so Vf minus Vi, so that is a change in velocity. So we're starting, we're taking our final velocity, we're subtracting our initial velocity. That's the same thing as the change in velocity. So sometimes you'll see Vf minus Vi written simply as delta V. So that triangle means change. And then V here with our little arrow to show that that is has a direction to it. And so delta V. But let's back up here a little bit. Let's assume that we want to solve this for the initial velocity. So in the last example, we talked about two superpowers. Superpower number one, you can do anything you want to this as long as you do the same thing to both sides, right? So we could say we could multiply by a potato on that side. We can multiply by a potato on this side. There's some strange looking potatoes. And this formula is still equivalent. It still works. Though it's hard to plug potato into your calculator. The other superpower that we mentioned is that when you set up your equation, a situation where you have a value divided by itself, that those two things, something divided by itself, is just equal to 1, which essentially eliminates it from that side of the equation. So that's superpower number 2. But we have to be a little bit careful using that second superpower. Right now, if we take a look at our formula, we see that we are dividing by t. We are dividing the right-hand side of this equation by t, by time. And I want you to know that the way that this is written is showing that we are dividing both the final velocity and the initial velocity by time. We are dividing all of this whole thing here by time, not just one or the other. And so this, the fact that our initial and final velocity, one's being subtracted from another, does kind of muddy this situation slightly. But let's go through the process of solving for VI. So why don't we try to get rid of that t? So let's try to set up a situation where we have t divided by t, which is just equal to 1. And so in order to do that, we're already dividing by t on the right-hand side. So why don't we multiply t on the right-hand side too? And this is where we need to be a little bit careful. When we are multiplying t on this side, we are multiplying everything. We're actually multiplying this entire right-hand side by t. And that's fine as long as we do the same thing on the other side. Now let me rewrite this because we kind of have a lot going on here. And I'm going to show some steps in between. So here we have time times acceleration is equal to, now I'm going to write this as Vf minus Vi times t over t. This is essentially the same thing that we have written above. We could, if we want, rewrite this like this. So on the top we have Vf minus Vi times t, and that's what we have up here, Vf minus Vi times t. And on the bottom here, we have essentially 1 times t. And so it's not here, but there's essentially, we could place that 1 there. But in this case here, we do have that t over t that we were looking for. And so t over t is just equivalent to 1. So it doesn't need to be there. This 1 doesn't need to be there either. It's not really doing anything. It's just a placeholder. But let's rewrite this now to simplify it. Times acceleration is equal to Vf. Oops, it's a funny looking f. Vf minus Vi. So final velocity minus initial velocity. And we've greatly cleaned up the right-hand side by getting that t off of the denominator. Let's keep going though here. We said our goal is to try to get the initial velocity on its own. And so based on what we said here, you might be tempted to go, okay, we have the final velocity minus the initial velocity. Okay, well, if I divide both sides by the final velocity, you know, these should cancel out. This is where you have to be careful. Dividing Vf minus Vi divided by Vf is will not quite cut it. Let me back up, because this here is essentially the same thing as, let me rewrite this. Vf minus Vi divided by Vf is essentially this. We've essentially done this. We are dividing this entire top, right, this entire top by the final velocity. So if we break up that denominator, we could rewrite this as Vf divided by Vf minus Vi divided by Vf. And it is true that these two things here are equal to 1, and we haven't broken any mathematical rules. This does work. It just doesn't necessarily get us any closer to our goals. Vf divided by Vf is 1, and now we have minus Vi divided by Vf. And so it is true that these two sides are in fact equal. It just doesn't get us any closer to having that initial velocity on its own. And that's all because these two variables here are separated by a negative sign. So could be a positive sign, doesn't matter. But the fact that they're not being multiplied together means that we're setting up two fractions here. So this works in the sense that we're not breaking any mathematical rules. It just doesn't really get us that much closer to isolating our initial velocity. So let's back it up here. Let's say, okay, maybe we don't want to go this route. Maybe we want to try something else. Okay. So instead of dividing by the final velocity, let's see if we can approach this in a different way. So here we have Vf minus Vi. So how can we get rid of that if dividing by Vf means that we're dividing both of these, and that is going to make it a little bit more complicated for us. It's not going to get us in the direction that we want. Right now we have Vf. What if we were to subtract, just simply subtract Vf from that side? And we were to do the same thing on the other side, right? Superpower number 1. Let's rewrite this. Let's make it a little more simple. So time times acceleration minus the final velocity is equal to, so here we have Vf minus Vf. Well, in this case here, they are going to actually annihilate each other. So this is like having 5 minus 5, or potato minus potato, if we want to keep going with that example. But Vf minus Vf, that's just 0. So essentially what we have is 0 minus the Vi, minus the initial velocity. Well, we don't need to write that 0. It doesn't have to be there. So let's just rewrite it as negative Vi. So we still, definitely gets us in the right direction. We do have the VI on its own, except that it's negative, so we'll have to deal with that. But we were able to get rid of that final velocity. How do we deal with that negative? How do we turn that positive? How do we turn, rather, the initial velocity positive? One way to look at this is we can think of negative VI as negative 1 VI. So it would just be another way of writing exactly what we have already. So this maybe frames it a little bit different, though. How do we get rid of that negative 1? And so superpower number 2, if we can divide a number by itself, doesn't matter if that number is negative. If we can divide this side here by negative 1, that means that we can divide this side here by negative 1. We haven't broken any rules, mathematical rules. Negative 1 divided by negative 1 is just 1. And so what we've essentially done is we still have 1 VI, but it's positive now, and 1 times VI is just VI. So we've essentially isolated our initial velocity. So we can rewrite that there as just, we could say 1 VI, so 1 times the initial velocity, but 1 times anything is just that thing. So let's just write it like that to simplify things. And let's go over here. We could actually stop. We could say our formula, we could say, okay, initial velocity is equal to time times acceleration minus the final velocity divided by negative 1. We have technically isolated for our initial velocity, but we can clean up the left-hand side here a little bit. So let's do that. We could actually rewrite this. Remember, we have that negative sign here, so that plays with things a little bit here. Let's split up the denominator. So let's rewrite this as time times acceleration divided by negative 1 minus the final velocity divided by negative 1. And all this is going to do on that side there, when you divide by negative 1, really the only thing that it does is it flips the sign of that chunk of your equation here. So we can rewrite time times acceleration divided by negative 1 is just negative time times acceleration. And we can rewrite negative final velocity divided by negative 1 as just plus final velocity. So there, that's pretty good. That also works. We've simplified that. This negative up front is a little bit weird. So if we're being really picky, we could actually just like swap the places of these. Final velocity minus time times acceleration is equal to the initial velocity. And that's kind of the preferred way of writing it. But technically, we've solved for initial velocity in all of these examples. It's just this form of the formula is the most cleaned up. Nothing's really changed from the examples that we saw in the earlier video. The reason I wanted to approach it, do this example here, is just that we have to be careful. We have to recognize that when we are, say, multiplying an entire equation by a variable, that we're multiplying everything on that side. And so we have to kind of, we can't assume that we can just kind of cross things off willy-nilly, because sometimes, we are multiplying everything in here by that variable. There we go, as clear as mud.